How does a frisbee fly? When we throw a ball, we know it undergoes projectile motion, meaning that it arcs across the sky before hitting the floor. When we throw a frisbee, it stays in the air for a long period of time. Why does this happen? Physics is the answer. The main difference between a ball and a frisbee is the shape. Let's look at the shape of the frisbee. If we view it from side on, we can see that it's very similar to the wing of an aeroplane. Therefore, it's suitable to think that the frisbee flies in a similar way to an aeroplane. An aeroplane and a frisbee both have lift, but by the two main methods. The first method is called Bernoulli's principle. As we can see, the top of the frisbee is curved, and it is longer than the bottom side. As a result, when it's thrown, the air over the top covers more distance than the air moving under the bottom. Because it's travelling a greater distance over the same period of time, the air must be travelling faster. If you think of the air particles as cars in traffic, when they begin to move faster, there is a greater distance between them. When the cars move slower, they become closer together and more densely packed. This means that the air above the frisbee is less dense, and therefore has less pressure. In films, when the door of an aeroplane opens, we can see that everything is sucked out. This is because the air pressure inside is larger than outside. The same concept happens with the frisbee. They are sucked from the region of high pressure up to the region of low pressure, causing them to lift into the air. In this shot, we can see the frisbee flying upside down. Bernoulli's principle is acting, propelling the disc towards the ground, since the rounded side is facing down, yet it still seems to fly. This suggests that the objects don't require Bernoulli's principle to fly, meaning it is not the only component of lift. An object like a paper plane does not have this curved shape, but it continues to fly. Due to its large surface area, particles collide with the bottom of the plane, causing it to lift. This principle is known as Newtonian lift. It also happens to a frisbee. However, none of these effects are due to the frisbee spinning, so why must it spin? When we throw a frisbee without spinning, the front begins to tip upwards. This is because Bernoulli's principle tends to act on the front of the frisbee, not in the middle. This causes the front end to tip upwards and the frisbee becomes unstable. So why does spinning fix this? When a frisbee spins, the tipped side will turn away from the front, meaning there is a new tipped side, which in turn will again rotate away. This continues to happen as the frisbee spins through the air, keeping it stable. If you can spin the frisbee slowly, it wobbles through the air. All of these concepts lead to a frisbee flying through the air.